Hello students, today we are on page 451, that is lesson 9.5, which is on ratios and graphs. So if you're not already open to page 451, open your book there now so you can follow along and fill it in as we go. Today's shout out goes to Gurley and Mason B. These are two students that always work really hard. They always have their homework and they always do anything that I ask of them the first time. So way to be star students, you two, and today's video goes out to you. So yesterday's lesson looked at making ratio tables. So today we're going to take that knowledge and apply it to tables and graphs. So we're going to start graphing the information that you come up with in your data tables. So we looked at coordinate grids like this back, I believe, in chapter 4. So this should be nothing new. We're just relating it to ratios now. So today's solve and share says for every 4 adults at the beach one afternoon, there were 3 children. How many children were at the beach if there were 8, 12, 16, and 20 adults at the beach? So they give us this table to fill in. So I'm going to start by using the first ratio they gave us. So they said there were 4 adults for every 3 children. So in your table, I would fill in 4, and I'm going to make my writing here a little bit smaller so it actually fits in the chart. Okay, so there were 4 children or 4 adults for every 3 children. And okay. So then they want to know if there were 8 adults at the beach, how many children would there be? If there were 12, if there were 16, if there were 20. So I'm going to fill in the rest of this chart with those numbers. So 8, 12, 16, and 20. And when we looked at these ratio tables in the previous lesson, we saw that whatever the top row goes up by, it's multiplying. So it's doing like 4 times 2, 4 times 3, 4 times 4, and 4 times 5. So the bottom row has to multiply by the same amount. So 3 times 2 would be 6. 3 times 3 would be 9. Oops, I don't want to move my whole page there. I always forget to lock these. There we go. 3 times 2 was 6, 3 times 3 was 9, 3 times 4 would be 12, and 3 times 5 would be 15. So once we have our table filled in, these are going to become our coordinate pairs. So we said that a coordinate pair has to have an x value and a y value. Okay, so typically we see them like this. Our x value is our number of adults and our y value is our number of children. So I can replace my x and my y with my number of adults and my number of children. So I could plot 4, 3. So what I'm going to do is get my marker here. When there were 4 adults, there were 3 kids. Now there's no 3 on here because this side, this y-axis is going up by 2's. So I know that 3 would be halfway between 2 and 4. So I'm going to go over 4. I'm going to go halfway between the 2 and the 4 and put a dot right there. Okay, so now that I have plotted that point, I can plot the rest of them on my table. When you're doing these, a lot of times, especially on Study Island, they'll try to trick you up. So they'll put the number of adults on the top, and then on your chart, they'll put it on the opposite side so that you're kind of graphing them backwards from what you might think. So always make sure that your titles match up. So if I'm doing my number of adults is 4, I need to make sure that I'm going on my axis that is labeled number of adults when I find 4. And then when my number of children is 3, I need to make sure I go up to where it's 3 on the number of children side. So for our next one, it was 8 and 6. So I go over to where it is 8 adults. I go up to where there would be 6 children, and I put a dot. When there were 12 adults, there were 9 children. So again, I'm going to be halfway between the 8 and the 10 line. And when there were 16 adults, there were 12 children. So put a dot right there. And when there were 20 adults, there were 15 children. So again, halfway between the 16 and the 14. So if you do this correctly, it should make a nice straight line for you. I think I can make a dotted line here. Let's do a blue dotted line. So it should line up, all of your points should line up on a nice straight line if you did it correctly. If you do your graph and you have a point that's like way down here and the rest of your points kind of go in this line, you know that there's something wrong, that you graphed it wrong, or that there's a hiccup in your table, that maybe you didn't do your math right there. So whenever we're doing these make what we call a linear graph, or a straight line graph. So always make sure that your points are always in a nice straight line. Okay, so once you have that filled in, we'll take a look at the bottom. So Emery said that if there were 5 children for every 3 adults, sorry, there was an announcement. I had to pause my video. On the look back, it says Emery said that if there were 5 children for every 3 adults at the beach, and there were 25 children, then there were 15 adults at the beach. Is he correct? So the way I would set this up is I would set it up like a fraction and compare it that way. So if I have 5 children for every 3 adults, oops, let me change my line back to a regular line here. Okay, 5 children for every 3 adults. And I always think it's important to label children and adults. That way, I always get confused with which number is where, so it helps if you have them labeled. So if there are 5 children and 3 adults, then they said there would be 25 children. So when I label it, it just helps me to know that my children needs to go on the top because I had it on the top on the other one, and 15 adults on the bottom. So I want to check and make sure these are equal fractions. And the way that I do that is I make sure they multiplied by the same amount. So if I had 5, how would I get to 25? I'd have to multiply by 5. So then I check the bottom. Did they do the same thing? 3 times 5 would be 15. So that checks out. So is he correct? Yes, he is correct. The other way that you could check this, you could set up a ratio table like they had up here and fill it in with 5 and 3 and follow it up until you got to 25 children and look to see if 15 was the number at the bottom. Or you can make sure that they multiply this way. I think is a little bit faster, but if it is helpful to you to set up a table like this, that is completely fine as well. So if you need to pause the video so you can make sure that your graph is done correctly and you've got this filled in, pause the video. If not, I'm going on to the next page. So on page 552, they always give us an example problem. So it says, how can you use tables and graphs to show equivalent ratios? So it says Jake's Party Store, we can get 3 balloons for $2, 5 hats for $3, and streamers for $1. So it says Ellen is shopping for supplies at Jake's Party Store. Make a table to show how much Ellen will spend to buy 3, 6, 9, and 12 balloons. Then plot the pairs on a coordinate graph to find the cost of 18 balloons. So the first thing they did was they set up a ratio table. So they said the number of balloons that she bought first was 3, and we see on this sign that she can get 3 balloons for $2. So each time she doubles that number, her cost is going to double. So if she buys 6 balloons, 2 times 2 it would be 4. If she buys 9 balloons, she tripled the amount of balloons, so 2 times 3 would be 6. So that's how they fill in their ratio table. Once they have it filled in, then they can plot those points on a coordinate grid. So for every 3 balloons, it was $2. So we go over 3, up 2, and they have a dot right there. When there were 6 balloons, excuse me, there were $4. So if we go over 6, up 4, they have a point there. That makes this nice, neat line. One thing that's cool about ratio tables and plotting these charts, these graphs, is that we can look at the graph to find the cost for something that they haven't figured out yet. So they wanted to know what it's going to cost if she buys 18 balloons. Well, if my line goes in a straight line and I graph it and I have this nice straight line, I can go over on my graph and find whatever number I want. So they want to know what would 18 balloons cost. I follow that line up and I see where would it hit my dotted line. And it looks like it would hit it at $12. So I know the cost of 18 balloons would be $12. I could check that because I know that 3 times 6 would be 18 and 2 times 6 would be 12, so that does match up with the ratio. But a lot of times if we have a nice graph like this that we can look at, it's faster just to look at the graph and then you don't even have to calculate it. You can just see where it hits your line and that would be your corresponding cost. So it says, how can you use the graph to find the cost of 15 balloons? So again, I can find where 15 is on my x-axis, so it would be in between the 14 and the 16. Follow that up to where it hits the dotted line. It looks like it hits it about there. If I follow that line over, I could see that it would be $10. So we would have that answer that we just talked about. So find 15 on the x-axis, so we went over and found 15, then go straight up until it hits the dashed line, and that will help you find the y value, which was 10. So if you need to pause the video to write that down, go ahead. I'm going on to the next page. So this just gives another example. We said that when we're doing this, we are multiplying. Technically, I guess you could say that this side is adding the same amount and this side is adding the same amount. So this side is going up by 5s, this side is going up by 2s. So they show that in the graph as well, that your x-axis, every point is going to be 5 over from the one before it. So if I was at this point, I know the next point has to be 5 over. I know that the next point has to be 5 over. And then my y-axis is going up 2 each time, and that's because that's what it does in your table. So they just show you another example of a table and a graph. So it says, in another example, how could you use the graph to find the ratio of apples to 30 celery sticks? So when I look at this graph, if I go over to the 30 and follow it up to the dashed line, I see that the dashed line is going to hit the top of my graph here, which would be 12 apples. So we would do that the same way that we did on the previous page. So I type this in, find 30 on the x-axis and follow the line straight up until you hit the dashed line and find the corresponding y value, which was 12. So you can write that in. The other thing I could have done, if I see the last point was at 2510, you could go over 5 and up 2, and that would also put me at 12. So if you need to pause the video to get that in, you can. On the number 2, it says, do you know how? Complete the table to show equivalent ratios for 3/8. Then write the pairs of values as points to be plotted on the coordinate grid. So this side is going to go up by 3s. This side is going to go up by 8s. So if I'm going up by 3s, and I'm writing with my mouse, so this is probably going to be sloppy, we're going to have 3, 6, 9. Whoa, that's really bad. Let's try that again. 9, 12, and 15. Is if I add 3 each time, 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12, 12 plus 3 is 15. This side's going to go up by 8. So 8, 16, 24, 32, and 40. All that skip counting that you did back in 4th grade and 3rd grade is coming back to haunt you right now, huh? Okay, so I'm only going to do one of these. I'm going to let you guys do the other one. So I'll do number 4. I'll leave number 3 for you guys to do. So the first thing that I've got to do is fill in my table. So I can see that this side added, let's see, 5 to 25. So to get from 5 to 25, I know they weren't just adding up by 5s. So to get from 5 to 25, they would have had to have multiplied by 5. So if this side multiplies by 5, this side has to multiply by 5. Okay? So 5 times 2 would be 10. To get from 5 to 35, I know they multiplied by 7, so my other side has to multiply by 7. So 2 times 7 would be 14. So they're going by odd numbers here. They're going 5, 7, 9, 11. So 2 times 9 would be 18. And 2 times 11 would be 22. So you always want to check. You don't want to assume, because what I saw students, um, in my last group doing is they would just assume that each side was adding up the same amount, so they would just assume that this side went 5, 10, 15, 20, and they would go through and put 2, 4, 6, 8, 10. If you do that, you are going to mess up. So you got to make sure, you got to see what the one side is going up by before you do that. So if I'm going from 5 to 25, I know they're not just skip counting by 5s. They had to have multiplied by 5. So I'm going to erase this out of our way. And once you have your points, then or your pairs, your coordinate pairs, then you can graph it. So I'm going to go over 5, and when I look at this graph, they don't have every other line marked. So I know if this whole thing is 10, halfway between 0 and 10 would be 5. So I know that my graph is going up by 5. So it's 5, 10, 15, 20. They just didn't fill it in because there's not a lot of space along the x-axis, so they just wrote in every other number. So my first line, if I want to go 5 to 2, is going to be right here. Okay? And I can see the same thing on this side, like between 4 and 0, there's one line, so I know 4 divided by 2 would be 2, so this side is going up by 2's. The second point we had was 25, 10, so I'm going to go over to where 25 would be. That would be between the 20 and the 30. And then I'm going to go up to where my 10 would be, which would be between the 12 and the 8. So my second point should be right there. And then 35 to 14, I go over to the 35, which would be between the 30 and the 40. And I'm going to go up to where the 14 would be. If it helps you, you can go through and label these. I just can't do that with my mouse. Like, I can't write that small and make it look legible. And then 45 and 18, so again, between. And the last one we had was 55 and 22, and that isn't on our graph. Our graph doesn't go out that big. I could put a point up here in cyberspace where I think it would be, but I don't need to because that's as far as my graph goes. If you want to connect your graph with a dotted line, that is fine. Let me get where are my lines? Here they are. You can do that. That's up to you. Technically, all your points should lie in a straight line. And if you extend the graph out, it should hit that point that was there before. So if you need to pause it to get this down, that is fine. Where I move my page, my points might not be in the right spot now. We're pretty good. Move it over just a little bit. So if you need to pause it, go ahead and pause it. I'm going to take a look at the next page. So on this page, I think you guys can figure out this one. I'm going to say you can skip 6 and 7 and try to see if you can figure out number 8. So that's a few problems for you guys to do. I'll talk to you later. Bye.